Hello guys and welcome back to the channel. In this next section in our subject of networking, we'll be discussing network performance. So the first thing that's really relevant to this is understanding what loss is and how it occurs, and also what delay is and how they're related. So they are different, obviously. But network performance is determined through factors like these two, as well as another one called throughput, which I will discuss in the next slide. So loss just happens when data packets just simply don't reach their destination. And delay just refers to the time it takes for data to travel across the network. And as we can imagine, if we have a lot of delay, it means we're going to be lagging. And this is very important in real-time applications like video calls and especially video games. Because if you've ever been lagging in a video game, it's going to be lagging, and it's going to be lagging pretty bad. So through this diagram, we're going to be able to see exactly how this works. So we have two clients right here, which are going to be labeled A and B. And we have a buffer, which is just basically a waiting area for packets, and understanding because it's using packet switching, because as we see, there's many packets that are broken up into various chunks of data. But because this one is already full at this router, when we have this incoming one right here from B, because it's full, it's going to be lost. And that's gonna how the packet is going to be lost, because it just simply will not reach its destination because the waiting area or the buffer is already full. But once this chills out and once this starts transmitting data, as we see, it will move out of the buffer and it will be transmitted over to wherever it needs to go. So next up, throughput is a very important subject as well. And throughput just refers to the rate of successful data transmission. And as I said before, packet switching is a very important method in this, because it's a method that can transmit data by breaking it into these packets that are eventually routed over a network, which I just explained in the last slide. But this is just another one, because it measures how successfully this is carried out, essentially. Each packet can take a different path to its destination because of how broad the internet works and how many different ways there are to reach a destination through different protocols you can use. And the data is eventually reassembled there. Techniques like quality of service, which is just short for, which if you ever see QoS, Q and S are capitalized, this is what that means. And there's different load balancing. This prioritizes a really important traffic, and it distributes network loads evenly to prevent congestion. So as we see here, this is going to be another diagram. We're going to just basically say we're going to use a fluid going through a pipe as an analogy. We have the fluid is basically going to be the bits, and how fast it's going to be able to go through the pipe is going to be the rate. So as we see, it connects to the router at a rate of R bits per second, and it goes through another pipe all the way to the destination and back to where we need to go at a rate of R bits per second as well. And throughput is just measuring how successfully and how fast this is done. So again, how are packets lost? We just went over this in a few slides ago. We have two clients, A and B, but there's a full buffer. But because this one arriving here it's arriving when the buffer is already full, it's going to be dropped and lost because it's full and it can't go anywhere. And obviously the buffer will free up once several of these packets will be transmitted. How does queuing happen, and what defines transmission delay? Because these are very important in being able to understand network performance as well. Queuing occurs when a packet arrives at a switch or router faster than they can be transmitted, quite simply, which causes a delay. So if you've ever been at like the DMV and there's a very long line, this is called a queue, because there's only so many people that work at the DMV, but yet a lot more people are there to have stuff done that they need to have done. And transmission delay refers to the time it takes for the entire packet to be pushed on a link for transmission, which is very obviously dependent on how big the packet is and what the size is and what the rate actually is. As we saw in the last slide, the packet is the size of L bits. It carries through at a rate of R bits per second. And this is going to be just a transmission rate, how long it takes for it to reach its destination. That's it. So a little quiz question for you guys. What factor impacts network performance by causing data packets to be dropped? We have throughput, packet loss, transmission delay, or queuing. This should be pretty obvious, because if we have a full buffer, it's going to be B, packet loss, because it's going to be arrive at the buffer really when it's already full, and it's going to be dropped because it won't be able to reach its destination. So thank you guys so much for watching this next segment. In the last section, we would be discussing the security of networks. So stay tuned. Thank you very much.